Dobry den. I'm going to talk to you about particle physics. Now, from the GCSE, you should be familiar with the concept of a neutron and a proton, and both of which are usually found in a nucleus, and we now classify these as nucleons at A level, and you should already know about the electron. What we now need to talk about is which family group of particles these come from. So, in terms of particle physics, I'm going to talk to you about baryons and mesons today, and I may just touch upon the lepton family as well. Right, okay, so what I'm going to talk to you about is hadrons. Okay, now hadrons are a family of particles that are made up from quarks or antiquarks. Okay, now that's new terminology for you. Don't be too concerned, I will go through the quarks and antiquarks with you as well. Right, okay, so out of the hadron family, you've got baryons and mesons. Baryons are made from 3 quarks. Okay, for example, a proton is a baryon, and also a neutron is a baryon. Okay, now a proton is made from an up quark, and a down quark. A neutron is made from an up quark, a down quark, and a down quark. Okay, now baryons are unstable, okay, if not part of a nucleus. Okay, the most stable baryon is a proton. Because of this, okay, all baryons eventually decay into protons. So they eventually decay into protons. So, for example, if a neutron is outside of the nucleus, then it's got a half-life of typically 11 minutes, and it will eventually decay into a proton. Okay, so that's an example of neutron decay. You do also get antiprotons, and all it is it's the opposite quark. So you'd have an anti-up, an anti-up, and an anti-down. Now, I've talked to you about quarks. Let's go through what these are. So quarks are the building blocks for the baryons and the mesons. Okay, so your up quark has got a charge of plus 2/3. It's got a baryon number of plus 1/3, and it's got a strangeness of 0. More about strangeness later. Okay, in terms of your down quark has got a charge of minus 1/3. It's got a baryon number of plus 1/3, and again, it's got a strangeness of 0. In terms of your strange quark, that's got a charge of minus 1/3. It's got a baryon number of plus 1/3, and it's got a strangeness of minus 1. Strangeness is the tendency of particles to decay into kaons, but we'll talk more about strangeness in another session. Okay, so if we look at the composition of a proton using this table, an up quark is plus 2/3, an up quark is plus 2/3, and a down quark is minus 1/3, which is equal to an overall charge of 1. Thus justifying the composition of a proton. Okay, mesons are particles that are a quark and antiquark pair. Okay, so mesons are a quark and an antiquark pair. Okay, now they don't last for very long. They decay into protons. So decay into protons, and they also sometimes decay into leptons. Now, leptons are fundamental particles, so it means they're only made from themselves, and they do not experience the strong nuclear force. So, for example, an electron is equal to a lepton. It is only made from itself it's not made from quarks. Okay, so if I talk to you about the mesons that you need to be aware of, you need to be aware of pions, and you need to be aware of kaons. And remember earlier I did say that strange particles decay and form kaons as part of their products. Okay, now to make things slightly more complex, but it's nothing that we can't cope with, you have got pi neutral, pi plus and pi negative, and you've also got kaons that are neutral, K plus and K negative. Okay, now you need to be able to establish the quark compositions of each, and you're simply using the table. Okay, so in terms of kaons, for your K neutral is strange and it's anti-down. Now, the reason why we've mentioned strange particles here is because kaons involve strangeness, okay, which is something I've mentioned earlier. So this has got a relative charge of a strange particle of minus a third, and then your anti-down is plus a third, so therefore that renders it neutral because they cancel each other out. K plus is up and anti-strange, and K negative is strange and anti-up, so the opposite. You do also get an anti-K neutral, and that is where the roles are reversed in terms of anti-quark and quark pairing. Okay, in terms of the pions then, pi neutral can be up anti-up rather, down anti-down, or strange anti-strange. Okay, so you've got a choice of 3 for up and anti-down. It's your pi plus, and if you're still keeping score of this, that's plus 2/3 and plus a third because it's the opposite, which gives us a charge of 1 overall. And in terms of pi negative, that's down and anti-up. Now, this is something that's going to require further reading. You do need to understand particle physics for your A-level, especially for the sections that are coming up on exchange particles, Feynman diagrams, and the conservation laws. What I'd recommend to anybody is look through this, go through it step by step, and use a textbook to back you up. Some people choose to remember, okay, the baryons as the baryons, Burley as in hench, okay, and that's because they're a combination of 3 in comparison to the measly mesons, which is this sleek, slender number, small pairing there. So the Burley baryons and the measly mesons. Essentially, you just remember what works best for you. There will be more details to come in a future video. Dziękuję or dziękuję. Thank you.